Hi, this video is about the prediction of first activity of units combinational forces. Initial ideas. Imagine you had a card with two fan units mounted on it and that push on the card in opposite directions and with different strengths. Now suppose you turn both the fan units on and give the card a quick show along the track in the same direction that the stronger fan is pushing. The force diagram above represent the situation just after your hand has lost contact with the card. The question is, what do you think the motion of the card would be like just after your push? Would its speed increase, decrease, or remains reasonable constant? What do you think so? The motion of the card would be increased because the stronger fan and the speed are at the same direction, and even though after the push. Other questions. Suppose that you repeated the experiment, but this time give the stationary card a quick show in the same direction that the weaker fan is pushing. Again, the force diagram represents the situation just after your hand has lost contact with the card. How do you think the speed of the card would behave now, just after your push? Why do you think so? The speed of the card decrease because the weaker force and the speed are at the same directions, even though after the push. The other part, um, suppose you had a low fraction card that has two fan units mounted on it that both push it in the same direction with individual force strength of 30 newton and 20 newton card 1. If this card was initially held at rest with the fans turns on and then released, what would happen? The card speeds out. The other questions, do you think card 1 would start to move or not? And if it did, what do you think would happen to its speed as it did so? Increase, decrease, or remains constant? What do you think so? I think the card starts to move and increase in the speed because um, both fans are in the same directions, and this shows that both of the force are in the same directions. Other questions, if you could vary the strength of the force the single fan unit applies to card 2, what value do you think it should have to make card 2 behave in exactly the same manner as card 1? Why do you think this force strength would work? If you want to behave the card 2 in the exact manner of the card 1, should be the force of the card, the force that acts on the card 2, almost the same as the force that acts on the card 1. And the other questions, does card 1 start to move or not? And if so, how does its speed behave? Does this agree with your prediction? This question is after watching the movie 1. Yes, I think the card 1 starts to move and speeds up. Other questions, which value for the strength of the single force being applied to card 2 made it move in exactly the same manner as card 1? Is this what you predicted? I think the value of the same speed that comes on the card 2 made it move the same as the comes on the card 1. Yes, I predicted, when more than one force acts on an object at rest, but they all push-pull in the same directions, how can you determine the strength of a single force that would have exactly the same effect? Both strength would be at the same directions. Other part, how do you think card 1 will move now, if at all, when released? Not move, increase or decrease in speed, or move at a constant speed? Explain your reasoning. I think Because of the strong force that comes on the left card pushes in these pictures, the um, strength push comes from the left, 30 newton, and 20 newton push, the weaker comes from the right to the card. The left side is stronger, the right side, and the card little moves to the right. And other questions: do you think the weaker 20 newton force will have any effect on the motion of the card, or will it behave in exactly the same manner as if only the 30 newton force were acting on it? Explain your thinking. Yes, the weaker force will have an effect on the motions of the card, but is the less than the stronger force, and it doesn't see anymore. And other questions: what value do you think the strength of the single force on card 2 should have now, so that its motion will exactly match that of card 1 with the two opposing forces? Again, explain your reasoning. For matching the force and the motion of the card 1, the card 2 has to push to the right. The force that comes from the left to the card 2 should be stronger on it, and push to the right. Does the speed of the card 1 behave in the way you predicted after watching the movie 2? Yes. Which value for the strength of the single force being applied to card 2 made it move in exactly the same manner as card 1? Is this what you predicted? That the card 2's force and the motion would be the same as card 1. The force should be at the same directions. When more than one force acts on an object at rest, but they push-pull in opposite directions, how can you determine the strength of a single force that would have exactly the same effect? I think the amount of a single force that comes would be the same as the two opposite forces that comes on the card 1.